Hello, I'm Zach, and in the latest lab today, I'll be covering BGP, which stands for Border Gateway Protocol. Briefly, before I start the lab, I would like to discuss routing protocols. As we know, a more convenient and useful routing protocols to use in a large network with many devices is or are dynamic routing protocols instead of static routing protocol, which is only for smaller environments. But in an enterprise environment, typically, you have many devices, so we employ dynamic routing protocols, okay? And those are grouped into two categories, as you can see here. In the green, you have the interior gateway protocols. So these usually happen in your LAN. They happen in your LAN, as I said, and they split up into two categories. You have distant vector routing protocols, which include RIP, IGRP, and EIGRP. Quite simply put, these routing protocols differ to link state routing protocols in that they don't have the global view of the network. They don't have the global view of the network, and they rely on information about the topology of the network from their neighbor. Whereas link state routing protocols like OSPF and ISIS, they have a global view. Each router has a global view of the entire topology of the network. There are other differences between distant vector and link state routing protocols. However, those are the ones that I will mention for now. But this lab is all about the yellow side. Okay, you have your exterior gateway protocols. There's only one that's in use, that's common, should I say, and that is BGP. BGP is anything that happens once you leave your LAN and you go to the wide area network, okay? So it happens on the outside of the router, and the IGPs happen on the inside of the router, typically. Here is a summary of the Cisco BGP best path selection. In the following lab, I will be focusing on the first BGP attribute for path selection, which is weight. And as you can see, the higher the weight, the more preferred. This is the topology that I will be using for the BGP lab. Briefly, you can see two autonomous systems, AS1 and AS2. Router 1 is in AS1, whereas router 2 and router 3 are in AS2 together. They both have identical loopback addresses in the same autonomous system. I've got my three routers here. If I verify the interfaces to see that they are pre-configured correctly, yep, this one is all fine. If I check here as well, I see both of my interfaces that are connected to each router and the loopback as well. Excellent, same thing here. So all three routers are pre-configured correctly, with R2 and R3 both having a loopback address that are identical. They both are 2.2.2.1 with a /24 for the network as the mask. Okay, so before I configure BGP, this could potentially cause us a problem, because for neighbor adjacency to happen in BGP between the routers, each router must have a unique router ID. Okay, and the problem here is both of these routers, R2 and R3, have identical loopback addresses. So to avoid that problem, when I am configuring BGP, what I will do is I will enter a manual router ID on each and every single one of these routers. So if I start with R1 and I assign it with an AS number of 1, because router 1 is in autonomous system 1, okay, and I give it the BGP router ID of 1.1.1, simple, and then if I connect it to its neighbor, so this R1 here is connected to two neighbors, so the first neighbor is 192.168.12.2, okay, so with a autonomous number of 2, okay. If I do the same thing for the other interface, this interface here going towards R3, so now it should be good to go from this point on. Excuse me. Okay, so if I do the configuration for BGP on router 2 now, yep, BGP 2 this time because we are on a different autonomous system. Okay, so if I do the router ID and the neighbors as well, so its other neighbor is R3. So if as you can see there, I've just got a notification saying that the adjacency has been achieved between router 1 and router 2. So if I do the same thing for the other interface going towards R3, which I believe has an IP address of 23.3, yep. This time it's in the same AS, so AS2. And also like to advertise the loopback address, the network on the loopback address, which is a /24 mask network. That should be set. Finally, if I do the same thing here, okay, I've given it its own unique router ID. Next, I will attempt to establish the BGP neighbor adjacencies. So the first one is going towards R1. Okay, and the second one is going towards R2. So if I just do that, it should form two neighbor adjacencies now. That there's one going towards R1, and there's the second one, the second BGP neighbor adjacency going towards R2. Okay, so one last thing is I should also advertise the network of the loopback address here as well, which, as I said before, is identical to the loopback address on R2. Okay, so now we should be set. What we can do is check the BGP table on R1, because R1 is receiving the 2.2.0 network from R2 and from R3 simultaneously. So we can see on BGP, on the BGP table here, how it selects which route will go into the IP table, IP route table. Okay, so as you can see here, the preferred route, the best route, which is signified by this on the BGP table, is via router 2. Okay, for the 2.2.2.0 network, and that is because of the factor that is known as the router ID. So there are so many different ways to choose the preference in terms of path, and because there was a tie in all of the other BGP factors including weight, local preference, where it originates from, whether it's locally or not, the AS path. Because all of those things match, the router ID was the tiebreaker, and because R2 has the lower router ID, it was chosen as the primary route, or the best route that is chosen for the 2.2.2.0 network. Okay, so as you can see here, the weight is 0. Okay, the lowest weight possible. Weight is a metric that is used, or it's a factor that is used to determine the best BGP path. It's Cisco proprietary, and the higher the weight is, the more likely that that path will be chosen. Okay, so if I just quickly show you, for example, here on this router, the BGP table, you can see here that the weight this time here is the maximum weight, which is, or the default weight, sorry, for the originated locally network. So because the 2.2.2.0 is originally located from this router, it has been given a weight of 32768. So this signifies that this network here was originated here locally. Okay, so what I will attempt to do now is to manipulate you to use BGP, because BGP, there's so many different ways to configure, and so many different methods that you can use to get your desired path. So in this scenario here, what I'm going to do is I'm going to change the best path from this one here, which comes from R2. I'm going to attempt to make it come from R3 and prefer this one. Okay, so to receive the 2.2.0 network from R3 instead of R2. How will I achieve that? There's different ways I can achieve it. The first way that I can show you is to change the weight attribute per neighbor. Okay, so how do I do that? I simply go on router BGP1, and then I assign the neighbor R3. So this is R3 that I'm doing now, and I make sure that any prefix or any routes that come in have an weight of, for example, 500. Okay, so that way it is more preferred, because the higher the weight is, the more preferred the route is, and the more likely it will be in your routing table for BGP. Okay, so BGP can be a bit slow sometimes to update the changes, so what I'll do is I'll restart it so that we can see the changes take place. Okay, so the adjacencies have gone down, and in a minute now, there you go, they're coming back up. So now if we check the BGP table, there you go. Now the other route is preferred, the other router is preferred. So now instead of coming from here, the network is being advertised from here because of the changing weight. Okay, weight is the first attribute that is looked at to determine which path will go in the BGP table. Okay, so it's now come from router 3. However, let's say for instance we wanted to, let's say there was more than one network on R2 and R3 that were coming towards R1, because for now there's only one network being advertised. Okay, and the neighbor command that I put in here, this neighbor command that I put in basically means any route that comes from R3 here will have a weight of 500. So it could be from any network. But if I, for instance, introduce another interface. So for instance, if I create an interface, let's say this one here. Okay, so that's an IP address of 22.22.22.1. So I've created another loopback address. If I just advertise that into BGP, with BGP you must be careful, because when you're putting in the network, it has to be an exact match. Okay, unless you enable auto summary, it must be an exact match. It must match the network that is on your router. Okay, so if I do the same thing here as well, if I make that same loopback address here, and I advertise that into BGP as well, okay, so now from R1 I should be receiving the 2.2.2.0 network, as well as the new one that I've installed now, which is the 22.22.22.0 network. Okay, so if I go back to R1, if I go on the BGP table, yes, there you go. So as you can see here, because I put the neighbor wait attributes command, both these networks have preferred to come from R3 because of the wait attribute. So in this lab we covered BGP. We looked at in particular the wait attribute when it comes to path selection. As I said before, wait attribute is Cisco proprietary. Okay, it's an attribute that is Cisco proprietary, and the higher wait is always preferred. I used a route map in one scenario. In another scenario, I used the neighbor command to set the wait. Okay, so that I can get the path set, so I can manipulate the path to the one that I desire. There are so many other factors that can be used for BGP path selection for the best path. Some of them include AS path or local preference, among other things. Do stay tuned on this channel, TechTrek, as I'll be covering more technologies that are used in production environments to get the best business outcome. I will also be covering many topics that are CCNP level, as I also study for the NRC exam.